Hello, and welcome to AI Unplugged, the podcast that explores the fascinating world of artificial intelligence. I'm your host, Nova, and today we're diving deep into one of the most interesting, and some might say intimidating, technological frontiers of our time: frontier AI models. Have you ever wondered what exactly makes an AI frontier level? Or perhaps you're curious about how these ultra-advanced systems might change your life in the coming years? Well, you're in for a treat because today's episode unpacks all of this and more. Before we jump in, though, I want you to imagine something. Picture the most powerful computer you can think of. Now multiply that power by thousands, add the ability to understand images, text, and speech simultaneously, and give it the capacity to learn from minimal examples. That's just scratching the surface of what frontier AI models can do. Let's break down today's journey. First, we'll explore what actually defines a frontier AI model. Then, we'll look under the hood at the technical innovations making these systems possible. Next, we'll examine real-world applications already transforming industries. And finally, we'll tackle the ethical challenges and future directions that keep AI researchers up at night. Ready to explore the cutting edge? Let's dive in. So what exactly makes an AI system frontier level? It's not just about being the newest or shiniest model on the block. Frontier AI models represent the absolute pinnacle of artificial intelligence capabilities today. They're the Formula One race cars in a world of regular vehicles, pushing boundaries in ways that weren't possible even a few years ago. Let's talk about scale first. You might have heard terms like parameters thrown around in AI discussions. Think of parameters as the knobs and dials that an AI system can adjust as it learns. Traditional AI systems might have millions of parameters. Frontier models? We're talking trillions. That's 1,000 billions, a truly mind-boggling scale. But it's not just about size. What truly sets frontier models apart is their architectural sophistication. These aren't just bigger versions of older systems. They incorporate revolutionary new designs. Take GPT-4 Vision, for example. It uses advanced attention mechanisms that allow it to process text and images simultaneously. Imagine having a conversation with a system where you can show it a photo and ask questions about it, and it understands both inputs perfectly. You might be thinking, that sounds impressive, but what makes this different from the AI that's already in my smartphone? The key difference is adaptability. Frontier AI models excel at what researchers call zero-shot or few-shot learning. Have you ever had to explain something over and over to get your point across? Frontier AI doesn't need that repetition. Show it just one or two examples of a task, or sometimes none at all, and it can figure out what you want. This means these systems can tackle problems they weren't explicitly trained to solve. Another defining feature is multimodal integration. Earlier AI systems were specialists, good at text, or images, or sound. Frontier models are more like Renaissance intellectuals. They excel across multiple domains simultaneously. Google's Gemini, for instance, can process video, text, and sensor inputs all at once, generating outputs that consider all this information in context. This is crucial for applications like self-driving cars or advanced robotics, where understanding the complete environment is essential. And here's something that might blow your mind: context windows. The latest frontier models can maintain coherence across what developers call context windows, exceeding 1 million tokens. In practical terms, that's like having a conversation where the AI remembers everything discussed in a 700-page novel. It doesn't just recall isolated facts, it understands how all the information connects. Perhaps most impressive is how these systems are becoming more accessible through edge deployment. Meta's Llama 3.2, for instance, uses clever techniques like quantization and pruning to run efficiently on smartphones. This means you can have powerful AI capabilities without sending your data to the cloud, enhancing both responsiveness and privacy. According to the World Economic Forum, hybrid systems that combine edge and cloud capabilities will dominate industrial AI applications by 2026. Think about what that means for everyday life: having access to incredibly sophisticated AI right in your pocket, working seamlessly with more powerful systems in the cloud when needed. Now, let's peek under the hood. What technical innovations are making these frontier models possible? One of the most fascinating developments is how these systems learn. Traditional machine learning often relied on straightforward techniques. Show the AI millions of examples and let it figure out patterns. Frontier models incorporate more sophisticated approaches like reinforcement learning from human feedback, or RLHF. You might be wondering how RLHF works. Imagine you're teaching a child to be polite. You don't just explain rules, you provide feedback on their behavior in real situations. RLHF works similarly. Human evaluators review the AI's outputs and provide feedback that helps align the model with human values and preferences. This creates systems that not only perform well, but also behave appropriately. Some cutting-edge research is even exploring quantum-inspired algorithms. While true quantum computing isn't yet mainstream in AI, researchers are borrowing concepts from quantum physics to solve particularly difficult problems, like simulating protein folding for drug discovery. Have you noticed how your laptop or phone gets hot when running intensive applications? Now imagine the heat generated by systems thousands of times more powerful. The energy requirements for training frontier models can be staggering, equivalent to the annual electricity usage of hundreds of households. This has led to breakthroughs in efficiency. Techniques like sparse attention mechanisms ensure these models don't waste computational power on irrelevant calculations. It's like having a spotlight that only illuminates important areas rather than flooding an entire room with light. Gradient checkpointing reduces memory consumption during training, making it possible to build larger models without proportionally larger hardware requirements. These efficiency improvements aren't just good for developers' budgets, they're essential for making AI more environmentally sustainable. Still, the computational demands remain enormous. Training the largest models requires specialized data centers with thousands of high-performance GPUs or custom AI accelerators working in parallel. This concentration of computing resources raises questions about who can participate in frontier AI development, a point we'll revisit when we discuss ethical considerations. So these models are technically impressive, but what are they actually doing in the real world? Let's explore some applications that are already transforming industries. In healthcare, frontier AI is accelerating drug discovery and enhancing diagnostic accuracy. Companies like in silico medicine are using AI to predict how molecules will interact with specific disease targets, dramatically speeding up the process of finding potential new medications. Have you ever waited anxiously for test results from a doctor? AI-driven diagnostic tools are significantly reducing error rates in interpreting medical images and tests. These systems integrate genomic data, medical imaging, and electronic health records to suggest personalized treatment plans, essentially delivering precision medicine tailored to individual patients. The financial sector has been an early adopter of AI, but frontier models take capabilities to new levels. Algorithmic trading systems now analyze not just historical price data, but also real-time news sentiment and macro trends to make split-second trading decisions. What's particularly interesting is how these models handle risk assessment. Traditional financial models often struggled with rare black swan events, those unexpected occurrences that dramatically impact markets. Frontier AI can identify subtle patterns that might precede such events, potentially providing early warnings of market instability. In cybersecurity, these advanced models are transforming threat detection and defense. They analyze network traffic patterns to identify potential attacks before they fully develop. Some systems can even autonomously respond to threats, patching vulnerabilities or isolating compromised systems without human intervention. You might wonder if this is just automating what human security teams already do. The key difference is scale and speed. A human analyst might examine a few dozen potential threat indicators in a day. AI systems can continuously monitor millions of data points across global networks, responding to threats in milliseconds rather than hours. These practical applications demonstrate why frontier AI isn't just a technological curiosity. It's already reshaping critical sectors of the economy and society. But as with any powerful technology, these capabilities come with significant challenges and risks. With great power comes great responsibility, and even greater ethical questions. As frontier AI capabilities expand, so do concerns about potential misuse and unintended consequences. One of the most concerning possibilities is the weaponization of these technologies. Advanced language models could be used to conduct sophisticated phishing campaigns or spread misinformation at unprecedented scale. Autonomous systems with access to critical infrastructure could become targets for exploitation. You might be thinking, surely developers are taking precautions against these risks? They are, But the challenge is that the same capabilities that make these systems useful also create potential for harm. A model that excels at writing creative fiction could also generate convincing fake news. A system designed to identify security vulnerabilities could potentially be reversed to exploit those same weaknesses. Bias represents another significant challenge. These models learn from vast data sets that inevitably contain human biases. Studies have shown differential performance in systems like facial recognition based on race and gender, perpetuating rather than solving societal inequalities. This is why there's growing emphasis on what's called explainable AI, or XAI. Rather than having black box systems that provide answers without explanations, developers are working on approaches that make AI decision-making more transparent and interpretable. The regulatory landscape is still evolving to address these challenges. The Frontier Model Forum, a consortium of leading AI developers, aims to establish safety standards for advanced AI systems. However, critics argue that self-regulation may not be sufficient given the potential stakes. Around the world, governments are taking different approaches. The European Union's AI Act creates a risk-based framework for regulating AI systems. The United States has focused on voluntary commitments while developing more comprehensive policies. China has implemented regulations specifically targeting recommendation algorithms and synthetic media. What makes regulation particularly challenging is the global nature of AI development. A restriction in one country may simply shift research to regions with fewer constraints. This highlights the need for international cooperation. A frontier AI arms race benefits no one. So where do we go from here? Let's explore some future directions for frontier AI that balance innovation with responsible development. One of the most exciting frontiers is AI reasoning. Current models, despite their impressive capabilities, still struggle with certain types of logical reasoning and planning. Future systems will likely incorporate more sophisticated reasoning abilities, potentially approaching something closer to human-like thought processes. You might wonder if this means AI will soon think like us. Not quite. Even as these systems become more capable, they're still fundamentally different from human cognition. They're tools with increasingly sophisticated capabilities, not electronic versions of the human mind. Another emerging trend is what researchers call agentic AI, systems that can act autonomously to accomplish goals. Imagine AI assistants that don't just answer questions, but proactively handle tasks on your behalf, scheduling appointments, researching options for major purchases, or managing your digital life. The reliability of these agentic systems remains a challenge. Current models sometimes produce incorrect information confidently, what researchers call hallucinations. Before we can trust AI agents to act independently, they'll need much stronger self-correction capabilities and clearer understanding of their limitations. Energy efficiency will continue to be a priority. Future frontier models will likely incorporate architectures specifically designed to minimize computational demands while maximizing capabilities. This isn't just environmentally responsible, it's economically necessary for widespread deployment. Perhaps most important will be evolving governance frameworks. The 2025 Frontier AI Safety Commitments represent early steps toward collaborative governance models that balance innovation with safety. Open science initiatives aim to democratize access to frontier AI capabilities while ensuring responsible use. The most promising path forward combines technological safeguards with thoughtful policy. Neither technology alone nor regulation alone can address the complex challenges these systems present. We need both technical innovations in safety and clarity on how these powerful tools should be governed. And that brings us to the end of our exploration of frontier AI models. We've covered a lot of ground today, from the defining characteristics of these cutting-edge systems to their technical foundations, real-world applications, ethical challenges, and future directions. Frontier AI stands at a fascinating intersection between unprecedented technological capability and profound responsibility. These systems have the potential to transform healthcare, revolutionize finance, enhance security, and reshape countless other domains in ways that benefit humanity. Yet they also present risks that require careful consideration and proactive management. The same capabilities that make them powerful tools for progress could, without appropriate safeguards, become sources of harm. What does this mean for you? In the coming years, You'll likely interact with frontier AI systems in both obvious and invisible ways, from more capable digital assistants to behind-the-scenes applications that enhance the products and services you use daily. Understanding these technologies, even at a high level, helps you participate in important conversations about how they should be developed and deployed. The future of AI isn't just for technologists to decide, it's a collective choice about what kind of technological society we want to build. I hope this episode has given you insight into this rapidly evolving landscape. If you found it valuable, please subscribe and consider sharing with friends who might be interested in understanding the cutting edge of technology. Next time, we'll be taking a look at AI agents. Until then, I'm Nova, and thank you for listening.